Section 14.4, More Applications of Quadratic Equations. The objectives: use quadratic equations to solve applications involving A, the Pythagorean theorem, B, work, C, distance, rate, time, D, projectiles, E, geometry, and F, cost per person. Example 1. The length of a rectangle is 7 feet longer than the width. If one diagonal measures 13 feet, what are the dimensions of the rectangle? So for our solution, if there is a picture we can draw, I always think that's a very valuable thing to do, and that's what we're going to do here, is we're going to draw a picture to see what we're looking at. So here's a rectangle. We've labeled the diagonal with the dashed line at 13 feet. We know one side is x, and we're going to call the width. X plus 7 is our length. So the width is x. X plus 7 is the length of the rectangle. Then by the Pythagorean theorem, x plus 7 squared plus x squared equals 13 squared. We're going to distribute on the left, which gives us x squared plus 14x plus 49 plus x squared equaling 169 on the right. Collecting like terms and moving 169 to the left side by subtracting it from both sides, we have 2x squared plus 14x plus 49 minus 169 equals 0. Putting our constants together, we end up with 2x squared plus 14x minus 120 equals 0. We're going to factor out 2, our greatest common factor. It's going to leave us with x squared plus 7x minus 60 equals 0. We're going to factor again. So we still have our factor of 2, and then that trinomial is factoring into x minus 5 times x plus 12. So we have 2 times x minus 5 times x plus 12 equals 0. We're going to set each linear factor equal to 0. X minus 5 equals 0, or x plus 12 equals 0. Adding 5 to both sides, we get x equals 5. Subtracting 12 from both sides, we get x equals negative 12. We're talking about length, so we're throwing that solution away. A negative number does not fit the conditions of the problem. Thus, x equals 5 and x plus 7 is equal to 12. We can check to see if this really works by taking 5 squared plus 12 squared and seeing if that equals 13 squared. So we have 25 plus 144. Does that equal 169? And 25 plus 144 is 169. So our solutions check, which means the width is 5 feet and the length is 12 feet. Example 2. Working for a janitorial service, a woman and her daughter can clean a building in 5 hours. If the daughter were to do the job by herself, she would take 24 hours longer than her mother would take. How long would it take her mother to clean the building without the daughter's help? In this problem, we're going to set up a table. We're going to have one column for hours to complete, one column for part completed in 1 hour, and then we'll have a row for mother, a row for daughter, and a row for together. We're going to let x equal the time for the mother to do the job alone, and x plus 24 equal the time for the daughter to do the job alone. So for the mother, it takes x hours to complete the job, so the part completed in 1 hour would be 1 over x. For the daughter, it takes x plus 24 hours to complete the job. The part completed in 1 hour for the daughter would be 1 over x plus 24. If they were doing the job together, it would take 5 hours. The part completed in 1 hour of them doing the job together would be 1 over 5. So the part done by the mother in 1 hour plus the part done by the daughter in 1 hour should equal the part done together in 1 hour, which means 1 over x plus 1 over x plus 24 equals 1 over 5. We're going to multiply each term by the LCM of the denominators, or the lowest common multiple, which in this case is 5x times x plus 24. So here you'll notice we're taking 5x times x plus 24 times each of these terms. With this first one, the x's are going to divide out. With the second one, the x plus 24 is going to divide out. And with the third one, the 5's are going to divide out. So what we're left with is 5 times x plus 24 plus 5x equaling x times x plus 24. Distributing, we have 5x plus 120 plus 5x equals x squared plus 24x. We're going to set it equal to 0 by moving these two 5x's together as subtracting 10x from both sides. We're also going to subtract 120 from both sides. So I have 0 equals x squared plus 24x minus 10x minus 120. Collecting like terms, we have 0 equals x squared plus 14x minus 120. That factors, and I'm left with 0 equals x minus 6 times x plus 20. I'm going to set each linear factor equal to 0. X minus 6 equals 0, or x plus 20 equals 0. Adding 6 to both sides gives me x equals 6 for my first solution. Subtracting 20 from both sides gives me x equals negative 20. We're talking about time, so that solution is going to be thrown out. It means that the mother could do the job alone in 6 hours. Example 3. A small plane travels at a speed of 200 miles per hour in still air. Flying with a tailwind, the plane is clocked over a distance of 960 miles. Flying against a headwind, it takes 2 hours more time to complete the return trip. What was the wind velocity? The basic formula is D equals RT, which is distance equals rate times time. That formula can be manipulated to be solved for time or for rate. If I solve for time, it's T equals distance divided by rate. And if I solve for rate, it's rate equals distance divided by time. We're going to let x equal the wind velocity. Then 200 plus x will be the speed of the airplane going with the wind, which is a tailwind. 200 minus x will be the speed of the airplane returning against the wind, which is a headwind. And distance is 960 for each way. We know the distance and can represent the rate or speed, so the formula time equals distance over rate is used for representing time. Once again, we're going to use a table to help us organize. We're going to have a column for distance, a column for rate, and a column for time. We're going to have a row for going and a row for returning. The distance going is 960. The rate going is 200 plus x. Time is distance over rate, so that's 960 over 200 plus x. The distance returning is 960. The rate returning is 200 minus x. Once again, time is distance over rate. So on the returning trip, that's 960 over 200 minus x. The time returning minus the time going is equal to the difference in time. So we have 960 over 200 minus x minus 960 over 200 plus x equals 2. Multiplying by the lowest common multiple, we're going to have 200 minus x times 200 plus x. That's our LCM. We multiply that times each term. In this first one, the 200 minus x's are going to divide out. In the second one, the 200 plus x's. And over here, unfortunately, nothing divides out. What that leaves me with is 960 times 200 plus x minus 960 times 200 minus x equals 2 times 40,000 minus x squared. This piece right here is what you get when you multiply out the 200 minus x times 200 plus x. All right, now we're going to distribute 192,000 plus 960x minus 192,000 plus 960x equals 80,000 minus 2x squared. So here, 192,000 minus 192,000, those are going to add to be 0. I'm going to add 2x squared to both sides, subtract 80x from both sides, and do a little collection of like terms. So I have 2x squared plus 1,920x minus 80,000 equals 0. We're going to divide everything by 2, which will leave me with x squared plus 960x minus 40,000 equals 0. That factors into x minus 40 times x plus 1,000 equals 0. So my two linear factors are x minus 40 equals 0 or x plus 1,000 equals 0. When I add 40 to both sides, I get x equals 40 on the left. When I subtract 1,000 from both sides, I get x equals negative 1,000. And once again, a negative number does not make sense, so we're going to throw that solution out, which means the wind velocity was 40 miles per hour. We can check this by taking 960 over 200 minus 40 minus 960 over 200 plus 40 and see if that really does equal 2. That's 960 over 160 minus 960 over 240. Does that equal 2? And that's 6 minus 4. 6 minus 4 is 2, so it's a true statement. Example 4. A bullet is fired straight up from ground level with a muzzle velocity of 320 feet per second. Part A, when will the bullet hit the ground? For our solution in this problem, v sub 0, which is our initial velocity, is equal to 320 feet per second, and h sub 0, which is our initial height, is 0 feet. The bullet hits the ground when its height h is equal to 0. Our formula is h equals negative 16t squared plus v sub 0t plus h sub 0. So we have 0 equals negative 16t squared plus 320t plus 0. That gives us 0 equals t squared minus 20t after I divide both sides by a negative 16. When I take out my greatest common factor of t, I have 0 equals t times t minus 20. So my two linear factors are t equals 0 or t equals 20. And the bullet hits the ground in 20 seconds. The solution, t equals 0, confirms the fact that the bullet was fired from the ground. So the trajectory of this bullet's going to be up and back down. So part B, when will the bullet be 1,200 feet above the ground? So in this case, h is equal to 1,200. So we have 1,200 equals negative 16t squared plus 320t. Setting that equal to 0, we have 0 equals negative 16t squared plus 320t minus 1,200. Again, we can divide everything by a negative 16, which leaves us with 0 equals t squared minus 20t plus 75. And that factors into 0 equals t minus 5 times t minus 15, which means t could either be 5 or t could be 15. And both solutions are meaningful. The bullet is at a height of 1,200 feet twice, once at 5 seconds while going up and once at 15 seconds while coming down. Example 5. A square piece of cardboard has a small square, 2 inches by 2 inches, cut from each corner. The edges are then folded up to form a box with a volume of 512 inches cubed. What are the dimensions of the box? A hint, the volume is the product of the length, width, and height. V equals LWH. Again, we're going to draw a diagram to help us figure out what this looks like. So we have a rectangle, or square, and then we have each of these little squares cut out of the corners. So that's 2 inches by 2 inches. And so if we take the total length of each side of the rectangle square as being x, then this little piece here is x minus 4. So we're going to let x equal the length of one side of the square piece of cardboard. Then the length is x minus 4, the width is x minus 4, and the height is 2 for the actual box we're going to get. So again, we have x minus 4, and 2. So length times width times height equals 512. So we divide both sides by 2, which leaves me with x minus 4 times x minus 4 equals 256. We're going to distribute, which gives me x squared minus 8x plus 16 equals 256. Subtract 256 from both sides. I have x squared minus 8x minus 240 equals 0. That factors into x minus 20 times x plus 12 equals 0. My two linear factors are x minus 20 equals 0 or x plus 12 equals 0. I'm going to add 20 to both sides, which gives me x equals 20. I'm going to subtract, then the other distance will be x minus 4, which is 16. With the other solution, I'm going to subtract 12 from both sides. x equals negative 12. Again, I'm talking about length, so I'm going to throw that one out. Can't have a negative distance. The dimensions of the box are 16 inches by 16 inches by 2 inches. So 16, 16, and the height is 2. Example 6. A Little League baseball field is in the shape of a square with sides of 60 feet. What is the distance to the nearest tenth of a foot the catcher must throw from home plate to second base? So that's the little red dashed line. And here you see your 60 feet. So the distance from home plate to second base is the hypotenuse of a right triangle with sides of length 60 feet. We can use the Pythagorean theorem as follows. X squared equals 60 squared plus 60 squared. X squared equals 3,600 plus 3,600. X squared equals 7,200. So we can take the square root of both sides. So x is equal to the square root of 7,200. Normally we say plus or minus, but again, we only want a positive square root. X then is approximately equal to 84.9 feet when we round to the nearest tenth of a foot. The catcher must throw about 84.9 feet. Example 7. The members of a bowling club were going to rent a bus to drive them to a tournament at a total cost of $2,420, which was to be divided equally among the members. At the last minute, 2 of the members decided to drive their own cars. The cost to the remaining members increased $11 each. How many members rode the bus? For our solution, we're going to let x equal the number of club members and x minus 2 equal the number of club members who rode the bus. So the final cost per member is going to be $2,420 divided by x minus 2. We're going to subtract the initial cost per member, which would have been $2,420 divided by x. And that's going to equal the difference in cost per member, which was 11. So once again, our lowest common denominator would be x times x minus 2. So we're going to multiply everything times x minus 2. So in this first one, the x minus 2's are going to divide out. In the second one, the x's are going to divide out. And then once again, nothing divides out there. So once we distribute what's left, we have 2,420x minus 2,420 times x minus 2 equals 11x times x minus 2. Distribute once again, we have 2,420x minus 2,420x plus 4,840 equals 11x squared minus 22x. This 2,420x and this 2,422x are going to add to 0. So all I need to do is subtract the 4,840 from both sides. That leaves me with 0 equals 11x squared minus 22x minus 4,840. We can divide everything by 11, which gives us 0 equals x squared minus 2x minus 440. That factors into 0 equals x minus 22 times x plus 20. We're going to go ahead and see that solutions would be x equals 22 or x equals negative 20. And again, we throw out the negative number because we're talking about number of people and we can't have a negative number of people. So if x is equal to 22, x minus 2 is 20. The final cost per member would have been 2,420 divided by 20, which would have been $121. The initial cost per member would have been 2,420 divided by 22, which would have been $110. And 121 minus 110 is 11. So we know that 20 members rode the bus.